हेलो गाइस, आप लोग कैसे हो? मैं अजीत प्रताप यादव आप लोगों के लिए नई वीडियो लेके आ गया। आज इस वीडियो में डिस्कस करेंगे क्लास 10th का साइंस चैप्टर 11 इलेक्ट्रिसिटी। तो ये वीडियो क्या है, एजुकेशनल पर्पज से है। तो लेट्स स्टार्ट। इस वीडियो को मैंने क्या है 8 पार्ट्स में डिवाइड किया है। पर तो नाउ आई विल डिस्कस द चैप्टर 11 इलेक्ट्रिसिटी 100 डिटेल क्वेश्चन एंड आंसर। इलेक्ट्रिक चार्ज एंड करंट पार्ट 1। I will discuss electric charge and current. Question number one: What is electric charge? Electric charge is fundamental property of matter that causes it to experience a force in an electric field. There are two types of positive and charge: positive and negative charge. What is an electric charge? Electric charge is a fundamental property of matter that causes its experience a force in an electric field. There are two types of charge: positive and negative charge. What is SI unit of electric charge? SI unit of electric charge is Coulomb. Define 1 Coulomb. 1 Coulomb is the charge transferred when a current of 1 ampere flow in for 1 second. Charge transfers when a current of 1 ampere flow 1 for 1 second in a conductor. 1 C equal to 1 A multiplied by 1 second. Define 1 Coulomb. 1 Coulomb is the charge transferred when a current of 1 ampere flow for 1 second. 1 Coulomb equal to 1 ampere multiplied by 1 second. Question number 4. What is electric current? Electric current is the rate of flow of electric charge through a conductor. It is like the flow of water in a pipe. Electric charge is the rate of flow of electric charge through a conductor. Rate of flow of electric charge through a conductor is called electric current. Question number 5. What is the SI unit of electric current? The SI unit of electric current is ampere. Define 1 ampere. 1 ampere is the flow of 1 coulomb of charge per second. 1 ampere equal to 1 coulomb oblique 1 second. Question number 7. Write the formula of electric current I in term of charge and time. I equal to Q upon T. Question number 8. In is electric current is scalar or vector quantity? It is scalar quantity. Although charge flow in a direction, current is defined at its magnitude. Is electric current is scalar or vector wave? It is scalar quantity. Although charge flow in a direction, current is defined by its magnitude. Question number: What is the conventional direction of electric current? Conventional current flow from positive terminal to the negative terminals of battery. This is opposite to the flow of electron. Question number 19. What is the conventional direction of electric current? Conventional current flow from positive terminal to the negative terminal of a battery. This is opposite to the flow of current. Question number 10. What is the actual direction of electric flow? Electron flow. What is the actual direction of electron flow? Electron being negatively charged flow from the negative terminal to the positive terminal of battery. Question number 11. Calculate the current flowing if 300 coulomb of charge pass through a wire in 1 minute. Given 1 Q equal to 300 coulomb, time 1 minute equal to 60 seconds. So I equal to Q upon T. 300 coulomb upon 60 seconds equal to 5 ampere. Question number 12. How much charge flow through a wire carrying a current in 10 seconds? Given I equal to 2 ampere, T equal to 10 seconds, Q equal to I into 2 ampere multiplied by 10 equal to 20 coulomb. Question number 30. How long will it take for 0.5 ampere current to flow if 15 coulomb of charge is passed? Given Q equal to 15 coulomb, I equal to 0.5 ampere, T equal to Q upon I. 15 coulomb upon 0.5 ampere equal to 30 seconds. Question number 14. What instrument used to measure electric current? An ammeter is always connected in a series in a circuit. What it means to measure electric current? An ammeter is always connected in series in a circuit. Question number 15. How is an ammeter connected in circuit? It is connected in a series so that that entire current to be measured flow through it. Question number 16. What is electric circuit? A closed continuous path made of conducting material through which an electric current can flow is called electric circuit. What is an electric circuit? A closed continuous path made up of conducting material through which an electric current flow is called electric circuit. Question number 17. What is the role of switch in circuit? A switch is used to complete on or break off the path of current in a circuit. Question number 18. What constitute an electric current in a metal wire? The flow of negatively charged electron constitute the electric current in a metal wire. Question number 19. What is the charge on an electron? The charge on electron is 1.6 multiplied by 10 to power minus 19 coulomb. Question number 20. How many electrons constitute 1 coulomb of charge? Number of electron n equal to total charge upon charge of 1 electron. So n equal to 1 upon C upon 1.6 multiplied by 10 to power minus 19 coulomb equal to 6.25 multiplied by 10 to power minus 18 electrons. How many electrons constitute 1 coulomb? Number of electrons Q equal to Ne. N equal to total charge upon charge on electron. So 1 upon C equal to 1.6 multiplied by 10 to power minus 90 coulomb equal to 6.25 multiplied by 10 to power 18 coulomb. Now part 2. We will discuss part 2, potential difference and Ohm's law. Question number 21 to 40. Question number 21. What is electric potential difference? The work done to move a unit charge from one point to another point in an electric field. It is the electrical push that causes current to flow. Question number 20. What is electric potential difference? The work done to move a unit positive charge from one point to another in an electric field. It is the electrical push that causes this current to flow. Question number 21. What is electric potential difference? The work done to move a unit positive charge from one point to another in an electric field. It is the electrical push that causes current to flow. Question number 20. What is the SI unit of potential difference? Question number 22. What is the SI unit of potential difference? The SI unit is the volt. Question number 23. Define the volt. 1 volt is the potential difference between the 2 points when 1 joule of work is done to move 1 coulomb of charge from one point to the other. 1 V equal to 1 J upon C. What instrument is used to measure potential difference? A voltmeter is used to measure the potential difference. It is always connected in parallel across the components. Question number 25. How is the voltmeter connected in circuit? It is connected in parallel across the 2 points between which potential difference is to be measured. Question number 26 states Ohm's law. Ohm's law states that at a constant temperature, the current flowing through a conductor is directly proportional to the potential difference B applied across its ends. V proportional to I, V equal to I into R, where R is the resistance. Question number 26 states Ohm's law. Ohm's law states that at a constant temperature, the current I flowing through a conductor is directly proportional to the potential difference V applied across its end. V proportional to I, R, V equal to I into R. Where are the resistance? Question number 27. What is the mathematical expression for Ohm's law? B equal to I into R. What are the conditions for Ohm's law to be valid? The physical condition like temperature of the conductor must remain constant. Question number 29. What is the electric resistance? Resistance is the opposition to flow of electric current offered by a conductor. Question number 29. What is electric resistance? What is electric resistance? Resistance is the opposition of flow of electric current offered by conductor. Question number 30. What is the SI unit of resistance? The SI unit of resistance is the ohm. Question number 30. Define 1 ohm. A conductor has a resistance of 1 ohm if potential difference of the volt across its end cause a current of 1 ampere to flow through it. 1 ohm equal to 1V upon 1A. What define 1 ohm? A conductor has a resistance of 1 ohm if potential difference of 1 volt across its end cause a current of 1 ampere to flow through it. What is the cause of electrical resistance? Resistance is caused by the collision of the following electron with a fixed ion upon atom in a conductor. Question number 33. Draw a typical VI graph for an ohmic conductor like metal wire. What does it show? The graph is straight line passing through the origin. It shows that the V is directly proportional to I, verifying Ohm's law. Question number 34. What does the slope of the VI graph represent? The slope of VI graph represents the resistance of the conductor. Slope V equal to IR equal to R. Question number 35. A wire has a resistance of 10 ohm. What current will be flow if the potential difference of 20 volt is applied? Given R equal to 10 ohm, V equal to 20 volt, I equal to V upon R. So V 20V upon 10 ohm equal to 2A. Question number 36. Calculate the potential difference required to push a 0.5 ampere current through a 24 resistor. Given I equal to 0.5 ampere, R equal to 24 ohm, V equal to I into R equal to 0.5 ampere multiplied by 24 ohm equal to 12 volt. Question number 37. Find the resistance of a resistor if the potential difference across it is 6 volt and current through it is 0.2 ampere. Give V equal to 6 volt, I equal to 0.2 ampere, R equal to V upon I. 6 volt upon 0.2 ampere equal to 30 ohm. Question number 30. Why does the resistance of conductor change with temperature? As temperature increases, the ions in the conductor vibrate more vigorously, increasing the frequency of collision with the following electron, thereby increasing the resistance. Name a non-ohmic resistor. A semiconductor diode is a non-ohmic resistor. Its VI graph is not a straight line. Question number 40. What happened to the current in a circuit if its resistance is doubled while the potential difference remain constant? From Ohm's law, V I equal to V upon R. If R is the double, V is the constant, the current become half. Part 3. Factor affecting resistance and resistivity. On what factor does the resistance of conductor depend? Resistance depend on the length of the conductor R proportional to L, cross section area A of the conductor R proportional 1 upon A, the nature of the material, resistivity, temperature of the conductor. Question number 42. State the relationship between resistance and length of the wire. Resistance is directly proportional to the length of the wire. R proportional length of wire higher the resistance. State the relation between the resistance R and area of cross section A of the wire. Resistance is inversely proportional to the area of cross sectional area of conductor R proportional 1 upon A. Thicker the wire, lower the resistance. Question number 44. Combine the factor to write the formula for resistance R equal to PL upon A, where R is rho is the resistivity of the material. Question number 45. What is the resistivity of a specific resistor? Resistivity is the resistance offered by the conductor of unit length and unit cross-sectional area. It is a property of the material. Question number 46. What is the SI unit of resistivity? Ohm meter. Define 1 ohm meter. A material has a resistivity of 1 ohm if wire of that material 1 meter long and with the 1 meter square cross sectional area has a resistance of 1 ohm. Question number 48. What does the resistivity signify about a material? Resistivity signifies the intrinsic ability of a material to oppose the flow of electric current. A good conductor has low resistivity and a poor conductor insulator has a high resistivity. Question number 49. Why is copper used for making electrical wire? Copper has a very low resistivity, about 1.7 multiplied by 10 to power minus 8 ohm meter, making it an excellent conductor of electricity. Question number 50. The length of a wire is doubled. What is the effect on its resistance? Since R proportional to L, if the length is doubled, the resistance also doubles. Question number 51. The area of cross section of a wire is doubled. What is the effect of its resistance? Since R proportional to 1 upon A, if the area is doubled, the resistance becomes half. Question number 52. A wire is stretched to a double its length. What happened to its resistance and resistivity? When stretched, its length doubled and its area become half. So resistance become 4 times the original R proportional L upon R. However, resistivity of rho remain unchanged as it is a property of the material. Question number 43. Why are alloy like nichrome used in heating element? Alloy like nichrome have high resistivity and high melting point. So they get very hot without melting when a current passes through them. Question number 50. List the resistivity of a conductor B and alloy and insulator. So conductor copper 10 to power minus 8 ohm meter. Alloy nichrome 10 to power minus 6 ohm meter. Insulator glass 10 to power 12 ohm meter. Question number 55. Why is the tungsten filament used in an electric bulb? Tungsten has high resistivity and a very high melting point, 34 degrees Celsius. So it can be heated to a high temperature to emit light without melting. Question number 55. Why is the tungsten filament used in electric bulb? Tungsten has a high resistivity and very high melting point, 34 degrees Celsius. So it can be heated to a high temperature to emit the light without melting. Question number 56. Calculate the resistance of a copper wire 2 meter long and with a cross sectional area of 1 multiplied by 10 to power minus 6 meter square. Resistivity of copper is 1.7 multiplied by 10 to power minus ohm meter. Given L equal to meter, A equal to 10 1 multiplied by 10 to power minus 6 meter square, rho 1.67 multiplied by 10 to power minus 8 ohm meter, R equal to rho into L upon A equal to 1.7 multiplied by 10 to power minus 8 multiplied by 2 upon 1 multiplied by 10 to power minus 6 equal to 3.4 multiplied by 10 to power minus 8 upon 1 multiplied by 10 to power minus 6 equal to 0.034 ohm. Question number 57. A wire of resistance of 10 ohm is stretched to twice its length. Calculate its new resistance. When the length is doubled, volume remain constant. So area become half. Now new resistance R dash equal to rho upon 2L upon A upon 2 equal to 4. PL upon A equal to 4 into R. 4 multiplied by 10 ohm equal to 40 ohm. Question number 50. How does the resistance of an insulator change with temperature? The resistance of an insulator decrease with an increase in the temperature. How does the resistance of an insulator change with the temperature? The resistance of an insulator decrease with an increase in temperature. Question number 59. What is the superconductor? A superconductor is a material that has zero resistivity when cooled below a certain critical temperature. Question number 60. Why is series of arrangement not used to domestic circuit? In a series arrangement, if one appliance fails, the circuit break and all the other appliances stop working. Also, the total resistance become very high, reducing the current. Why is series arrangement not used for domestic circuit? In a series arrangement, if one appliance fails, the circuit break and all the other appliances stop working. Also, the total resistance become very high, reducing the current. Question number 4. Series a parallel circuit. Question number 61 to 85. How are the resistors connected in a series circuit? Resistors are connected in end to end, providing a single path for the current to flow. Question number 62. What is the total resistance equivalent resistance for a resistor in a series? The total resistance is the sum of the all individual resistance R dash S R1 plus R2 plus R3. Question number 63. What is the current through each resistor in a series combination? The current is the same through every resistor in a series combination. Question number 64. How is the total potential difference distributed in a series combination? The total potential difference V is equal to the sum of the potential difference across each resistor. V equal to V1 plus V2 plus V3 dot dot. Question number 65. Two resistors of 2 ohm and 3 ohm are connected in series. What is the total resistance? R equal to R1 plus R2 equal to 2 plus 3 equal to 5 ohm. Question number 66. How are resistors connected in parallel circuit? Resistors are connected between the same two common points, providing multiple paths for the current. Question number 67. What is the total resistance equal to equivalent resistance for resistor in parallel? The reciprocal of the total resistance is the sum of the reciprocal of individual resistance. 1 upon R, 1 upon R1 plus 1 upon R2 plus 1 upon R1 dot dot. Question number 16. What is the potential difference across each resistor in a parallel combination? The potential difference across each resistor is the same and equal to the total potential difference applied. Question number 69. What is the total current distributed in a parallel combination? The total current is equal to the sum of the current through each parallel branch. I equal to I1 plus I2 plus I3 dot dot. Question number 70. Two resistors of 4 ohm are connected in parallel. What is the total resistance? 1 upon Rp equal to 1 upon 4 plus 1 upon 4 equal to 2 upon 4, 1 upon 4. Therefore, Rp equal to 2 ohm. Question number 71. What is the total resistance in a parallel circuit less than the smallest individual resistor? In a parallel, the effective area of the current flow increase, making it easier to current to flow, hence reducing the overall resistance. Question number 72. Why is the parallel arrangement used in domestic wiring? In a parallel arrangement, each appliances get the same voltage 220 volt operate independently, and if one fail, it does not affect the other. Question number 73. Three resistors of 1 ohm, 2 ohm and 3 ohm are connected in series. Calculate the total resistance R. S 1 plus 2, 1 plus 2 plus 3, 6 ohm. Question number 74. Three resistors of 6 ohms, 6 ohm, 6 ohm and 6 ohm are connected in parallel. Calculate the total resistance. A equal to 1 upon Rp, 1 upon 6 plus 1 upon 6 plus 1 upon 6 equal to 3 by 6. 1 upon 2, therefore R dash P equal to 2. Question number 75. A4, 75, A, question number 75. A4Q ohm and F12 ohm resistor are connected in parallel. Calculate the equivalent resistor. A equal to 1 upon Rp, 1 equal to 1 upon 4 plus 1 upon 12, 3 plus 1 equal to upon 12 equal to 4 by 12 upon 1 by 3. Therefore, Rp equal to 3 ohm. Question number 76. In a series circuit with A 3 ohm and 6 ohm resistor connected to a 9 volt battery. Find the current in the circuit. Rs equal to 3 plus 6 equal to 9 ohms. V equal to 9 ohms. I equal to V upon R equal to 9 upon V equal to 9 ohm. 1 equal to 1 ohm. Question number 77. For the circuit above, find the potential difference across the 6 ohm resistor. A current through a 6 ohm resistor I equal to 1 upon V equal to I into R equal to I into 6 ohm. 78. In a parallel circuit, a 10 ohm and a 15 ohm resistor are connected to a 6 volt battery. Find the total current drawn from the battery. A current through 10 ohm I1 equal to V upon R1, 6 multiplied upon 10 equal to 0.6 ampere. Current through 15 ampere I2 equal to V upon R2, 6 upon 15 equal to 0.4 ampere. Total current I1 upon I2 equal to 0.6 plus 0.4 equal to 1.0 ampere. Question number 79. Calculate the total resistance for the previous question using the formula. A equal to 1 upon Rp equal 1 upon 10 plus 1 upon 50 equal to 3 plus 2 upon 30 equal to 5 upon 30 equal to 1.6. Therefore, Rp equal to 6 ohm. Verification. I equal to V upon R. Rp equal to 6 volt upon 6 5 equal to 1 upon N. Question number 80. Which will glow brighter if connected in series? A 6 watt bulb or 100 watt bulb, both rated the same voltage. In a series, the current is the same. The bulb with higher resistance will dissipate more power, P equal to I square, and glow brighter. The 60 watt bulb has higher resistance, R equal to B P. So the 60 watt bulb will glow brighter. Question number 81. Which will glow brighter if connected in parallel, as 60 watt bulb or 100 watt bulb? In parallel, the voltage is same. The bulb with the lower resistance will draw more current and dissipate more power, P equal to V square upon R. The 100 watt bulb has lower resistance, so the 100 watt bulb will glow brighter. Question number 82. What is the main disadvantage of the series circuit? The main disadvantage of is that if one component failed, the entire circuit breaks and all the components stop working. Question number 83. What is the main advantage in parallel circuit? The main advantage is that different appliances can be operated independently at the same voltage. Question number 84. What happened to the total resistance and current if the more appliances are connected in parallel? Connecting more appliances in parallel increase the number of paths in decreasing the total resistance. This causes the total current drawn from the source to increase. Question number 85. What is overloading? Overloading occur when the total current drawn by all the appliances in a parallel circuit exceeds the safe limit of the circuit, which can causes overheating and fire. Part 5. Heating effect of electric current, electric power. Question 56 to 100. What is the heating effect of electric current? When an electric current flows through a conductor, it generates heat due to the resistance offered by the conductor to flow the current. Question number 86. State Joule's law of heating. Answer. The heat produced in a resistor is directly proportional to the square of the current, I square, directly proportional to resistance, directly proportional to time for which the current flow, H equal to I square RT joules. Question number 18. What is the practical application of the heating effect of electric current? Electric iron, electric heater, electric kettle, toaster, fuse, and incandescent light bulb. Question number 89. What is the heating effect on undesirable in some cases? It causes energy loss in the form of heat in transmission wire and electrical devices, reducing their efficiency. Question number 89. Why is the heating effect of undesirable in some cases? It causes energy loss in the form of heat transmission wire and electrical devices, reduce their efficiency. Question number 90. What is the electric power? Electric power is the rate at which electrical work is done or electrical energy consumed. It is the product of potential difference and current. Question number 90. What is electric power? Electric power is the rate at which electric work is done or electrical energy consumed. It is the product of potential difference and current. Question number 91. What is the SI unit of electric power? The SI unit of electric power is what? Question number 92. Define 1 watt. 1 watt is the power consumed when 1 joule of electrical energy is used in 1 second. 1 watt equal to 1 joule upon 1 second. Also 1 watt equal to 1 volt multiplied by 1. Write the three formula for calculating electrical power. Why is the heating effect undesirable in some cases? It is in what is question number 90. What is electric power? Electric power is the rate at which electrical work is done on electrical energy consumed. It is the product of potential difference and current. Question number 19. What is the SI unit of electric power? The SI unit of electric power is watt. Define 1 watt. 1 watt is the power of consumed when 1 joule of the electrical energy is used in 1 second. 1 W 1 joule equal to 1 upon 1. Also 1 W equal to 1 B upon 1. Write the formula for calculating electric power. P equal to B I, P equal to I square R using B equal to I and P equal to B square upon R, I equal to B upon I. Question number 94. What is the commercial unit of electrical energy? The commercial unit is the kilowatt hour, kWh. Question number 95. Define 1 kilowatt hour. 1 kilowatt hour is the amount of electrical energy consumed when appliances of 1 kilowatt, 100 watt, 1000 watt power is used for 1 hour. 1 kilowatt hour equal to 1000 watt multiplied by 3600 second equal to 3.6 multiplied by 10 to power 6 joule. Question number 96. An electrical bulb is rated 60 watt to sub 220 volt. Calculate its resistance. Given P equal to 60 watt, V equal to 220 volt, P equal to B square upon R equal to B square upon P, 220 volt square upon 60 equal to 8.806.7 ohm. Question number 97. Calculate the power of electric motor that operate at 12 volt and draw a current of 3 ampere. P equal to B upon I equal to 12 volt divided by 3 ampere equal to 36 watt. Question number 98. A 100 watt bulb is used for 5 hours daily. How many unit kilowatt hour of the electrical energy are consumed in 30 seconds? Energy consumed per day equal to power multiplied time 10 100 W multiplied by 5 multiplied by H equal to 500 watt W at 0.5 kilowatt hour. Energy consumed in 30 days equal to 0.5 kilowatt 1 day multiplied 30 days equal to 15 kilowatt for 15 minutes. Question number 99. What is the purpose of fuse? A fuse is safety device that protect electrical circuit from a overloading and short circuit. It has low melting point and breaks the circuit when the current exceed a safe value. Question number 100. How is fuse connected in series circuit? A fuse is always connected in series with the live wire of the circuit so that entire current flow through it. I hope this detailed list of help you master the chapter on electricity. Best of luck for your study. जय हिंद जय भारत.